Welcome to Frankly Developing. I'm your host Frank, and today we'll learn a simple technique that helps you hack into your readers' brains. Have you noticed that despite your efforts, you really struggle to understand some piece of code? I'll show you why it's the code's fault if it violates the single level of abstraction principle, and how to easily change it such that the brain of a reader can process it much better. Before we dive into an example and all the details, don't forget to like and subscribe so more people can learn how to hack our brains in a good way. Take a look at this code and try to understand it. It's a lot of code, so hit the pause button, take your time. Done? Okay. Now, what is the intention of this code? What does it even aim for? What is it doing? You probably found that really hard, if you managed at all to understand what this was about, which is no wonder. But before I explain you why, let's get the neurological basis for why this happens to our brain. This goes back to a really old study from Miller in 1956, where they found out the short-term capacity our brain has, so the number of things we can think about at any one time, before we have to reach back to our long-term memory, which is also like computers with a short-term memory being very close to you, like fast caching structure. If you go to long-term storage, it takes a bit more time, it's more effort. The advantage that we have as humans is that we can think of individual things called chunks, where we can combine a lot of knowledge into a chunk of knowledge and think about that as a whole. So that brings us to abstractions. Things like a for loop, for example. You don't have to think about it like the syntax shows you, like a for and brackets and an initializer and a condition. You think of it as the whole for loop as one chunk. Like you're looping over a certain amount of things or certain numbers. Right? So that's one thing for you to think about. It's kind of one of abstraction. And that is what we can think about in general, but only about 7, well, plus minus 2, maybe. So that's not a lot. And that's the reason also why this code is so hard to understand. So let's take another look at the code and see these abstractions in action. When you look from the top to the bottom, there's like things like final, being unchangeable is an abstraction. You have a generic parameter with a model query for a car. A query in itself is kind of abstraction. You can see a builder pattern in action here. Then we get to conditions, which have two branches, true and a false. And we have negation. Two kinds of negations actually. There's like this exclamation mark negation, but also like is empty is a sort of negation. Then you have multiple different return points to understand. And next comes an instance of, which means you have to understand about type hierarchies and interfaces and concrete types and abstract types. And then you have a class cast to a different type of this hierarchy. Then there's a static method call. So a different call of method. It's statically reached, it's not from an object. Then you have some different abstraction called null, and you have a check against that, and so on and so on. You can see that there's like many different abstractions going on in this piece of code. And if each of them takes one chunk of your short-term memory capacity, you're basically out of chunks. Your mental capacity is gone. So if you want to also think about what this code actually does, what the intention is, the next higher level of understanding, I would need at least one chunk in your mind which is no longer available. And that's the single level of abstraction that we talk about here. What you really want in a piece of code is to have only one level of abstraction. So you only need one chunk of basic programming technology know-how, and then the rest of your mind, of your mental capacity is available to reason and think about what really matters. And if you violate it, like here, It's no wonder that you have a really, really hard time to understand what's going on and understand this big picture. Now let's take a look at how we can hack your brain into understanding such complicated code. The technique is actually very simple. You extract methods. Take a look at how this method would look like after we extract two major blocks into separate methods. It's still complicated, but that is because we talk about consistency here, which is a complicated thing in itself. But now, in terms of abstractions, if you look at it, there's only like logical operators, two method calls, and that's about it. So now we can wrap our mind around it. We have enough chunks of capacity available to think that, oh, consistency actually means this or that cannot be. So that's actually understandable. And if you dive into the other extracted methods, take a look at this one, for example, then you similarly see that there's a lot less of abstraction levels. So it's a lot easier to understand what is really going on, because we do not overload our brains with a lot of information chunks that we need to process. Now you know why sometimes we have a really hard time to understand code. It just uses up too much of our mental capacity. Understanding this and adjusting my own code to make it fit our brains has completely transformed the way I approach code. I'm thrilled to share this journey with you. Remember, it's not just about understanding code. It's about unlocking a whole new level of clarity, of making your intentions clear. So subscribe, hit that like button, and thank you for watching. As always, have fun developing.